Okay, for this question here, we want to be able to trace or copy the graph of the given function, f. So here, this is our function, f of x. And then what we want to do is we want to draw a graph that represents the derivative function. Okay, so let's take a look at the things that we need to identify first. So here, the derivative is estimated by drawing a tangent line to the point x, f of x, and then approximating its slope. Now, what we want to do is we want to look for horizontal tangent lines, and these are where the x-intercepts of the derivative function will be. So here we have a horizontal tangent, we have another horizontal tangent here, and we have a horizontal tangent here. So those are going to represent the x-intercepts on the derivative function. So let's go ahead and note that. So from here, we have an x-intercept that's located here. Again, here's another horizontal tangent, so we're going to have an x-intercept there. And then from here, we're going to have another x-intercept located on a derivative function here. Okay, so now let's go ahead and identify those. So there's our first x-intercept, there's our second x-intercept, and then here's our third x-intercept. Okay, so now the next thing we want to do is the following. We want to be able to then look for a corner, sharp points, or vertical tangents, and these cause a discontinuity in the derivative function. Well, when we look at this graph, we don't see a corner, we do not see any sharp points, and there aren't any vertical tangents. So we can then dismiss number 2. And then number 3, it says the derivative function will be positive where tangent lines of f of x have positive slopes, and negative where the tangent lines have negative slopes. So what I mean by that is, let's go ahead and identify the slopes. So here we can see that this is a steep tangent line, and we would estimate that to say, okay, maybe that might represent -8 for the slope. Okay, and then if we have another tangent line, let's say that becomes -4. Okay, then we get another tangent line to that, which is -2, and then another tangent line, which is -1. So therefore, you can see that the slopes are increasing, starting from -8 all the way to -1. So you want to take a look at this point of -8, okay, and that -8 is now going to then identify to be the slope. So let's go ahead and do that. So I'm going to go ahead and identify that slope. So if we take a look at this one here, here we have, let's say that goes all the way down to, let's say, -8. Okay, and then we have one at -4. Okay, and then we have one at -2. Let's say that we have another slope at -1. So basically what we're saying here is those are the points of the slopes. So that represents -8 on the y-axis on the derivative function. This would represent -4. Okay, -2. Now again, these are estimated points. So this doesn't necessarily mean that this is the actual numbers, because we're just estimating what that function is going to look like. So now we can go ahead and draw our first part of the derivative function graph. So from here, we can see that it's going to start out and then increase towards the first x-intercept. Okay, so again, that's going to represent the interval between this value and then this value. So now we need to take a look at the interval between here and then here. Okay, so what's happening with our slopes? Well, now here, this starts to, now we can see our slopes, they start to increase. Okay, So they are increasing. So let's say, this is positive 1, and then positive 2, and then positive 3. So therefore, we would say, okay, well now on the y-axis, if this represents 1, if this represents 2, and then if this represents 3, well again, we're going to look at those points, and then here we know that we have a point at 1, and then 2, and then 3. So therefore, that's where we can see what's happening with our graph. And again, according to our slope. So here we have the graph that's continuating to 3. Okay, so now we can see that these slopes are going to start to decrease. Okay, so as they are decreasing to 0, so they're going to become negative. So eventually these slopes are going to be negative, which means it's going to come back down to when we get a slope of 0. So what that means is it's now going to come back down and then go through the next x-intercept, which is 0. Okay, so now we want to take a look at what's happening between these two intervals. Okay, so between those two intervals, you can see that we're decreasing, so our slopes are going to be negative, 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 and then eventually they're going to come around and then turn positive, positive, and positive. So what that means is we have this graph that's going to be decreasing through the origin or the x-intercept of 0. And then it's going to climb back up to go through that x-intercept. And so now, after this interval from here to here, we can see that now our slopes are going to continue to get steeper and steeper. So they are going to continue to increase, and it's increasing without bound. So therefore, we would continue this all the way through. And therefore, this is going to represent the graph of the derivative function of this function.